Okay, so we're going to retest the 117 grain Hammer Hunter, this time shooting into a fresh 10% Knox gelatin block. This is what they call an organic compound, so it's going to show us the temporary cavity as well as the permanent cavity. These clear ballistics blocks are fantastic, but what they seem to fall short in is they don't imprint the stretch as well as the organic. So this bullet's going to be cooking pretty hard. We've got the chronograph set up, and hopefully we can get a good reading on it. And what we're really going to be able to see using a fresh Knox block is that temporary stretch cavity that we were not able to see yesterday when I was running the tests on the clear ballistics gel. I'm still waiting on the molds for from clear ballistics on the clear ballistics gel, so it's going to be a little bit before I can remelt those. So they are cloudy from yesterday's shooting, but really what we're mostly concerned with is this first 16 inches of penetration. So let's get testing. Okay, so we went ahead and shot the block. I came down and I picked the block up. I put it back here in this position. It was a perfect shot right in the center of the block. I made a little bit of an audible, and I moved the chronograph over in front of this block instead of over by the rifle, so that we had the impact velocity instead of the muzzle velocity. So the impact velocity was 3,262. The penetration was 29 3/4. We have it entered the center of the block, traveled the length of this block, and it ended up right here at the back end. What you'll notice is that the bullet kind of had like a had a yaw, and it drifted from center kind of up and off to the side. So we're going to go ahead and take a look at that. Okay, so we had to flip the block around because I didn't catch it at first, but the block had turned on itself. So this is the front, this is the rear. We had a perfect entrance at the front. It entered about 1 inch and then started its expansion, which is consistent with the results that we saw yesterday during the tests, entering about 1 inch into the block and then beginning its expansion. So entered a 1 inch, began its expansion, and what you're going to see here, this is going to be like all that stretch. So we have that stretch cavity, and it created a lot of damage in here. Now the fragments that I'm seeing are not like petals. I'm not seeing large petals. What I see here are going to be these smaller pieces of copper, more like gold flecks throughout the block. That is again pretty consistent with the other 117 grain Hammer Hunter loads that I was shooting yesterday. Again, just a lot of copper fragments. That's good or bad. That's up to you, what you like. And then it traveled through the block. It went until about the 8.5 inch mark was the larger cavity. So it went from about 1 inch until about 8.5, 9 inches, depending on how you want to judge it. We do have some larger cuts that had happened throughout the block, but I think that's more from stretch and breaking than it is from actually the bullet. And it landed down at 29 3/4 inches. I'll go ahead and dig this bullet out. You want to can you pan me up over here? Yep. Okay. So about 2 3/4 inches. It actually went right to the end of this block. It did not enter this block. To the end of this one, and it's just kind of thinking about its life there, if it wants to poke out or not, and figuring out its life choices. Let's cut that. Let's see what we got, and it's a really nice mushroom. I mean, I'm really impressed with that. That right there is my favorite part of this bullet. Okay, we've remelted the block. I've retrieved the fragments from the first shot that was at a high velocity. Impact velocity on that was 3,262 feet per second. Now we're going to go ahead and shoot the block again, this time using a starting charge weight, and which should reduce our velocity at impact. Impact velocity was 3,142 feet per second. This will simulate a 100-yard shot if you're using a full powered load. We got 25 inches of penetration. It's in the second block, didn't make it to the third one. We're gonna go ahead and cut this open and take a look inside. Okay, so we cut the block open. We had about an inch of penetration before expansion. The largest portion of the expansion went until about the 7-inch mark. Now we have greater wounding, but I don't believe that this was mechanical. I think this is stretching. So this is the nature of the tissue expanding when on impact. We did have the shedding of petals, so we have a lot of these fragments that we can go ahead and retrieve later. And then the bullet did reach 25 inches. So we have 25 inches into the block over here. Last time it was 29 3/4. And if you could see that right in there, we'll go ahead and cut it out and we'll show you in the post. Well, that second shot wasn't as slow as I was hoping for, but right now we're in the middle of a move, and I've got some powders that could go slower, but they're packed away right now, and I won't be able to get at that until after I've done the move. If you'd like me to do another video in the future going at a lower velocity with the 117 grain Hammer Hunter, just let me know in the comments below, and that way I know there's interest in doing so. So let's go over what we do have. This bullet impacted at 3,262 feet per second. This one impacted at 3,142 feet per second. So there's about 100 feet per second difference there. These are the fragments that came off of the first shot. They weigh 29.5 grains. This is the shank that came off the first shot. It comes out at 75.9 grains. Here are the fragments that came off of the second shot, and here's the shank that came off of the second shot. Now, it looks like the shank is a lot larger than this one, and it looks like the fragments are a lot larger. But when I weighed them, these weighed about 30 grains, and this weighed about 77 grains. So it's really not that much of a difference, 1 grain of a difference and half a grain of a difference. What you'll see here is that this one actually just had a much larger mushroom than this one did. And so the material is just peeled back more. At its widest point, the faster projectile was at 0.408, and at its narrowest point across, 0.371. This one penetrated 29 3/4 inches. This one penetrated at 25 inches. Now I want to give my thoughts regarding this fragmenting, because at first I didn't really know how to feel about this fragmenting. I'm not used to seeing this in a monolithic bullet. The only monolithic bullets I've shot in the past have been the Barnes bullets, and I'm used to Barnes having that where their nose kind of peels back into that mushrooming shape. Now that mushroom doesn't always stay together. So here's an example of a 110 grain Barnes bullet. That's that mushroom. And you could see it didn't stay on that bullet whatsoever. But that's what I'm used to when I'm looking at monolithic bullets. I wasn't used to this, and I didn't know how to think about it. But then I had a few moments to ponder, and I want to show you an example. This right here is a 140 grain Nosler ballistic tip. It's a good bullet. I like the way it performs. It started out life at 140 grains, and now it weighs 88 grains now. Now it's stable. Now it weighs 88 grains. So where did the rest of the lead and jacket go? Well, it's in the block. And if you're shooting an animal, it's going to be throughout the animal. That's part of the reason why some of these states, like New York and California, are having a problem with lead bullets, is because that lead is being found throughout the animal. Now, I don't think they should be regulating away lead bullets, but rather educating people and bullet manufacturers doing the best they can to duplicate the superb performance that we've had out of lead bullets. Lead bullets work. These things are great. The problem with lead bullets is the lead. Lead is toxic to people. And where did the rest of this bullet go? Well, it went into my meat. And so hopefully I'm able to cut out enough of the bloodshot meat that it's not going to be affecting my family, my wife, my children. But having something like a copper bullet
that's going to react like a lead bullet in the fragmenting. This is what a lead bullet does. Having a copper bullet that acts like a lead bullet perhaps will provide amazing terminal performance. A couple of other little nerdy points. We had somebody was asking me about the stability factor of these bullets. The guys over at the Hammer Bullets forum, I think it's called Hammer Time. If you want to check that out, they've got a lot of really great information over there. One thing that the guys are researching right now is something not only with the stability factor of bullets in flight, but stability, terminal stability. So stability when that bullet actually enters into an animal or a ballistics gel. They're finding that a higher stability factor of say 2 or even 3 helps that bullet to be able to perform more optimally and penetrate deeper than at a lower stability level. Now 1.5 is the minimum recommended stability level by the military. I think that the standard lowest is 1.3. So the stability factor of this bullet shot from my rifle was 1.573. I have a 1 in 10 twist. Now, if my 270 had a 1 in 8 twist, we may be seeing a much higher stability factor of say 2 or 3. But that's just some food for thought for you guys. Now, according to Hammer Bullets, these bullets are stable all the way out to, will expand all the way out to 1,800 feet per second. That's 675 yards. So this is, if all goes well, this is a 675 reliable bullet. My problem with shooting at 675 yards is this energy. Now, I know that a lot of people don't really care about the energy so much anymore, but I still want to maintain at least 1,000 foot-pounds of energy for a deer, especially if I'm using a monolithic bullet. I still don't have a whole lot of trust for a monolithic bullet at 1,800 feet per second. I think the guys that make this are fantastic. They're wonderful. If you go on their website, you can be able to call and even speak with the owner on the phone. They are fantastic guys, and they have full 110% confidence in their bullets. They use a softer copper alloy than say Barnes bullets or Hornady GMX. So they're saying, yeah, our bullets will expand down to 1,800, do their fragmenting like they're supposed to, and get your game. I would say if you're looking for 1,000 foot-pounds minimum on a deer-sized animal or an antelope or however, that's 575 yards. That's still pretty far out there. My personal limit would be 400 yards, which actually gets me 1,461 foot-pounds and 2,372 feet per second. So this is great. 400 yards in a 10-mile-an-hour crosswind, an 11.7 inches of wind drift. That's totally doable. 9 times out of 10, you're not going to have a constant 10-mile-an-hour crosswind. So you're going to be able to have a really reliable shot out to 400 yards with this bullet. So would I use this out to 400? Yeah, I think so. And I would feel even more confident after I reduce the velocity down to 2,300 feet per second. See what the expansion looks like. But those are my thoughts on these on this Hammer line of bullets. This is my first test on the Hammer line of bullets. I would like to get some more tests out on the Hammer. I've got some 124 grain, 308 diameter Hammer bullets. I want to test those in the future. If you guys have any suggestions, if you like this video, let me know. If there's anything that I can do to be able to improve on the data, if there's any information maybe that I'm missing and that I can improve on in future videos, please let me know in the comment section below, and I will do the best I can. Thanks for watching.